Welcome back. This is a second video about the atom. I wanted to actually start by reminding you, especially if you're in ILS as a ninth grade student, that don't forget that I have a Moodle site that you can access through my main web page through the school. And when you click on the Moodle, this is the Moodle site. I want to remind you that there's stuff for every unit. There will be stuff for every unit. And one of the things that I put up here was the same the PowerPoint that I'm using currently right now to show you these movies. And I also put on a couple links to kind of go over the stuff that you got in the last video on the history of the atom. So I've got a link here, and if you want to read about any of those guys, we in the last video talked about Democritus, we talked about Dalton, we talked about J.J. Thomson, Rutherford, and Bohr. And you'll find Bohr kind of down towards the bottom here. And you will I'm not going to make you memorize very silly things or anything, but you might want to read those over because I know that my video lectures are kind of fast. But if you're still like, who was Dalton, who is this guy, who's that guy, just click on these links here. They'll give you some good information. I'm going to go back to that PowerPoint that we were on with atomic history. When we left off, I was telling you about Niels Bohr, and I was telling you about how he proposed that the atom is got a nucleus that is positive, and it's got electrons that travel in a circle in an orbit around the nucleus. Kind of looking like that. Now, he proposed that every atom that every atom had a nucleus that was made up of of something he called protons, which he said were positive proton, and something that he said was neutral, so he called them neutrons. And then, like I mentioned, going around the orbit of that nucleus, he said, were these electrons. And even back at Dalton's time, most people had this idea that there was a negative or opposite charge to these electrons. So there's a proton, there's a neutron, and there's an electron. And then the orbits that I've told you about, sometimes they're called orbits, but sometimes they're called shells. So there's two electrons in this shell. There's one electron right here and one here, and they would be spinning around that nucleus. So, and these particles actually consist of even smaller particles, but we're not going to get into those here. And those are called quarks. So I think take a second, and I'm going to actually give you a second, and I'll pause, and you can pause the video. See if you can figure this out. What's the proton, neutron, electron? What's the charge, and what's the mass? Give you a second to do that. Alright, hopefully you've paused the video. If not, pause it now. And I'm going to start. Alright, so obviously we have a positive charge for a proton, and we say that protons have a mass of 1. Neutrons have no charge, and they also have a mass of 1. And electrons are considered to have a negative charge, and they are considered to be so light that we basically say they have nil mass or no mass. And I'll tell you why that's important in a second. So take a look at helium. Now, helium is an element that is atomic number 2. And that usually tells you something. And this 4 here tells you something too. So what I want to do is show you where you would go to kind of find out that information. Again, if you went back to Moodle, I've put an online periodic table here for you, and I've also got one in your packets for you. And if you look at nitrogen, for example, you're going to see, or helium. If you click a look at helium and you click on it, you can get all this kind of information about it, which I'm not going to make you know, but here's the kind of important stuff. It's atomic number 2, and it has a weight of 4. And you can see that when you look at the periodic table. You can see that it's atomic number 2. That atomic number is right up at the top there where it says 2. Okay, and so this is called the atomic number, and it always tells you the number of protons that a certain element has, a certain atom. Atomic mass is the number of protons plus the number of neutrons. And helium happens to have 2 protons and 2 neutrons, and since each one of those has a mass of 1, it's 2 plus 2, and it equals 4 is the atomic mass. In terms of the number of electrons that are going around the nucleus in the orbit, the number of electrons is always equal to the number of protons because atoms are neutral overall. They have the same number of electrons as they do protons. And again, in this video, since this is going to be somewhat new when you're watching this, you can always stop this or watch it again. So I know I'm going a little fast, but you have the opportunity to watch it a few times to kind of get the hang of it. So we call those electrons traveling in orbits or shells, and sometimes they're called energy levels. And those shells or orbits can only hold a certain number of electrons. The first one right around the nucleus can only hold 2 electrons, and then the next few can usually hold 8. And that's about all we'll get to in this class. And that is actually helpful when you're trying to draw what an atom is going to look like of a certain element. And there's 2 ways to show that. One is called the electron configuration, and the other one's called a dot. Sometimes it's called a cross. I call it a dot diagram myself, but a cross diagram. So how do you write it? Well, when you write it, you write the element's symbol from the periodic table. The top number you're going to write is almost always going to be the proton number, the atomic number, which is 7 for nitrogen. And then it's got a mass of 14, which means it must have 7 protons and 7 neutrons. So nitrogen, again, a total of 7 protons, 7 neutrons to make a mass of 14. And then, as we said, to make neutral, we're going to have electrons have to be equal to the number of protons. Pluses and minuses have to be equal. And in the first shell or orbit, we can put 2. In the second shell, we can put the other 5. Because remember, it goes 2 and then 8 and then 8 as a maximum. That's on the previous slide. So I want you to take a few seconds and guess these. And we can go over them in class and stuff. I'll put the answers up for you in a second too. But try these first. And again, I'm going to pause. You should pause your movie screen. Try these. See if you can figure out how many protons, how many neutrons, and then how many electrons would go into each of the levels. Okay, I hope you paused. If you didn't, then it's going to sound like I just started talking. But this is kind of the answers for the electrons. So calcium is atomic number 20. It happens to have a mass of 40, so it has 20 neutrons and 20 protons. Then it also has 20 electrons, so 2 go in the first orbit, then 8, and then 8, and then the last 2 go in the final orbit, which is the fourth one. Sodium, a little bit different. Sodium is Na, and it is atomic number 11, and it happens to have 12 protons because its mass is 23. 11 plus 12 makes 23. And for this one, it's going to be 11 electrons, so 2 in the first orbit, 8 in the second orbit, and then only 1 would go in the third because that'll equal 11. Oxygen, 8 protons, 8 neutrons for a total mass of 16. 2 electrons go in the first shell, 6 in the second for a total of 8 electrons too. Chlorine, 17 is the atomic number. Its mass is 35, so it has 18 neutrons, because 18 plus 17 is 35. And there's 2 electrons in the first orbit, 8 in the second, and then 7 in the last. Silicon, 14 protons, atomic number 14. 14 neutrons for a total mass of 28. And then there's going to be 14 electrons, 2 in the first, 8 in the second, and then again 4 in the last one to make a total of 14. And boron, atomic number 5, it has 6 protons. 5 plus 6 makes a mass of 11 on the periodic table. And for the electrons, since there's 5 electrons and 5 protons, because it's neutral, 2 electrons go in the first orbit and the 3 go in the second. Now again, I went over it. Go ahead and go back in the video and see if you can do it now without my help. You can always try that or try some other ones. And so when we make these diagrams to show what the atom of that element is going to actually look like, we either use dots for the electrons or crosses like X's for them. So that's why they're called dot or cross diagrams. So for example, nitrogen, here's the nucleus in the middle. You kind of have to pretend it's there. And again, that has 7 protons and 7 neutrons for a mass of 14. And then the first shell is going to have 2 electrons, and that's going to be this circle right here. And then the other one's going to have 5. And that equals 7. And there you can see them in the pretend circles. 2 in the first shell. There we go. And 5 in the second. The second and the third and the fourth levels can hold up to 8. So now I'm going to ask that you try that for this. I'll pause for a second and then I'll pop them up. Okay, so these are 2 of the same ones from the other page, but instead, this time I wanted you to draw them. Oxygen, again, would have 8 protons and 8 neutrons in the middle. It would have 2 electrons here, and then 6 more here, to make a total of 8. So 8 electrons going in orbit. Chlorine, obviously a little more complicated, 17 protons and 18 neutrons for a mass of 35. And since the proton number positive is 17, the electron number is also going to be 17. 2 go in the first, 8 go in the second, and 7 go in the third. So that third one's almost full in this atom. So to summarize, the atomic number of an atom is the number of protons. The mass is the number of protons plus neutrons. The number of protons plus is always equal to the number of electrons minus. Electrons orbit the nucleus in shells or orbits or energy levels, and each shell can only hold a certain number of electrons, 2 for the first level and 8 for the rest. And I got this from, I like to give credit, so I got this from a great website for teachers called World of Teaching, so you're welcome to check that out. It's really more for teachers, but you are welcome to try it out. So when we come back to class, if you have any questions or you can't do some of these things, that's what we start with, and then I don't have to lecture this material. So I hope that that works for you, and I hope that this video worked, and I will see you guys in class. Thanks a lot.